Hello and welcome. My name is Jasmine Kyles, and I'm sitting here today with some of our friends here from NVIDIA, which is one of our AWS partners. So I'm a manager of product management here at AWS. Happy to be joined by Spin and Arun. So tell us a little bit about you and who you are.
Thank you, Jasmine. Hello, everyone. This is Arun here. I'm a senior product manager in the deep learning software team at NVIDIA. I head product management for conversational AI and speech AI at NVIDIA.
Oh, thank you for the nice introduction, Jasmine, and thank you, Arun. I'm Sven. I'm a deep learning developer advocate at NVIDIA. I work on a mixture of developing, playing with, educating about, and evangelizing for NVIDIA's speech AI software, in particular the Reva SDK.
Awesome. I'm excited to learn more about that today. So we'll get to go through and see a little bit of demos, which everyone loves to see. They get to see how the products work and how quickly and easily they can get set up with it. So, we know that NVIDIA is no stranger to AWS, but for anyone here who might be new, who's watching, tell us, what is NVIDIA?
NVIDIA pioneered accelerated computing to tackle challenges that otherwise cannot be solved with traditional computing. We started out with a focus on gaming and computer graphics industries, and over the last decade, NVIDIA has become well known as the key enabler for AI through our GPUs and software stack, transforming industries valued at more than 100 trillion, from telcos to healthcare to finance, and profoundly impacting society.
Nice. That's definitely a very wide scope, right? And so now we're going to talk about Reva today. And that has a little bit of a more laser focus, right?
Yes, it does. Reva is a fully customizable GPU accelerated SDK for real-time speech AI and translation. I actually have a few slides that I can bring up to go into more detail on what Reva is and what it does.
Yeah. So why did you build Reva?
As we were talking to customers over the last several years, we found that they had three major challenges when it came to speech AI and translation. Number one was accuracy. It was really hard to get a conversational or speech AI pipeline to get the accuracy needed for very specific domains and use cases. Number two was many of these use cases needed to be real time, and you needed to get the output within a certain latency, let's say within 300 milliseconds, for the people interacting with the pipeline to have a realistic experience. And number three was the flexibility to be able to deploy this pipeline in the infrastructure that you were already using for your other pipelines and other infrastructure that you had. And there was no solution in the market that was clearly meeting the needs of customers. And that's why we built Reva, specifically focusing on these three different pain points.
Yeah, that's awesome. I think it's very compelling, right? When you're meeting the need in the market and helping people to be more efficient in the work that they do every day, especially around, being global, right? A lot of the customers that you support are working across teams that are not just in one place. And so this is important to making sure that they can be efficient in this area. Awesome. So you mentioned that you had some visual aids for us here. So let's go into that so we can see a little bit more about this and how folks would interact with Reva.
Yeah, absolutely. All right. So Reva, as I was saying earlier, is a GPU accelerated SDK for speech AI. It is packaged as a Docker container that can be deployed on the customer's infrastructure of choice. We have many customers who have deployed Reva on their AWS infrastructure. And once you deploy Reva, you will essentially have access to gRPC endpoints for three different capabilities. So the three capabilities are ASR, automatic speech recognition, NMT, machine translation, and TTS, speech synthesis. What speech recognition is going to do is take in audio input and provide transcripts with timestamps and with accuracy. The translation pipeline is going to take in either speech or audio input or text input in one language and convert that into text or speech output in a different language of your choosing. And the text to speech is going to take in text input and going to convert that into audio input in the way that you want it to be delivered. There are two ways of using the pipeline. Number one is just out of the box. So you are able to essentially take the Docker container with the pre-built models, and you're able to deploy it and just hit the server and use it. On the other hand, if you need better accuracy for your specific domains and use cases, you can also customize various parts of the pipeline and take those custom models, export that into Riva, and use that to get improved accuracy. Let's go to the next slide. So we discussed briefly about the pain points that customers were facing. How does Riva help with those? So number one is accuracy. Out of the box, Riva accuracy is better than most other solutions available in the market for speech AI. And on top of that, each piece of the pipeline, from the acoustic model to the language model to punctuation and capitalization models, are all fully customizable. A customer or a partner can customize those models and improve the accuracy of the pipeline. And the goal here is with Riva, a customer is able to get accuracy they are not able to get anywhere else. And number two, the entire pipeline is GPU accelerated. So every module is optimized with TensorRT, and the pipeline also uses Triton as the backend for serving the entire stack, meaning that if you wanted to run hundreds of thousands of concurrent streams, you're able to do it efficiently, and the pipeline is also optimized for the specific GPU hardware you're using, thereby resulting in reduced latency. And lastly, the pipeline can be deployed anywhere, including on AWS. And here are some examples of customers that have actually deployed Riva in production and that had a great experience using Riva for their speech AI needs. As an example, there is T-Mobile that had tried various other solutions in the past and found that for their agent assist solution, where in the real time, agent is seeing an agent in the contact center is seeing the transcripts of the conversation and is getting real-time insights based on the conversation that they then use for improving the overall customer experience. And as you can imagine, the accuracy of the transcript is really important in this particular agent assist use case. They tried various solutions. They found that the accuracy was not really meeting their needs. And with Riva customization, they were able to improve the accuracy by 3x over a period of just a couple of months. And this resulted in overall significant business value because of the improved customer satisfaction. Another example was RingCentral, which was using Riva for their video conferencing transcription, slightly different use case, but similar challenges, that the accuracy needed to be really good for the customers to be able to use the transcripts as well as to do additional post-processing operations on the transcripts. Let's say you wanted to summarize or you wanted to get specific insights based on the meeting notes. You needed the meeting notes to be really accurate. And then more recently, we also have an example of NCS, a company in Singapore that was developing a voice for a navigation app in Singapore. The challenge here was in Singapore, the addresses are a combination of multiple different languages. This is called Singlish. It's actually a combination of English, Mandarin, Malay, and Tamil. And there is no speech synthesis system in the world that can speak in Singlish because it needs to know all these different languages. And so the customer was able to take Riva, and because it is customizable, they were able to build a model specifically for the Singlish language. And they found that this really met their needs for the navigation app they were building. Those are some really cool examples of what customers have been able to do with Riva for their production needs. Next, we wanted to share a snippet of what some of our customers have been saying.
And so we chose to build our own T-Mobile speech-to-text using NVIDIA Riva. And that's why did we do it? Because it's faster, it's cheaper, and we have more control. And so Riva uses these pre-trained models. They are optimized for runtime, which is great because we have to be very fast in real time. They're highly customizable, so we were able to drop the word error rate, 18%. And we were very excited about doing it because we like to have control over what's happening. And we'll kind of get into why control in the speech space in particular is important to us.
Always great to hear your customers provide such glowing reviews of the product. And lastly, I also wanted to touch on how Reva fits into the overall NVIDIA ecosystem. So NVIDIA AI Enterprise is the platform for production AI targeted at enterprise customers who want to deploy AI in production. And Reva is a premium SKU that is part of the NVIDIA AI Enterprise platform. Reva provides the framework as well as the pre-trained models for customers looking to deploy speech AI and translation. It also comes with pre-built workflows, which are sample applications that customers can use to speed up their development. And it also includes the AI Essentials. What Essentials has is the enterprise-grade support, security, and reliability. It also includes over 50 AI frameworks, pre-trained models, and workflows for various different tasks. I think it would be really great to look at a quick demo of how Reva can actually be used in AWS.
Yeah, awesome. Thanks for that, Arun. Yeah, let's hear a demo, Sven. I know that you've put something together for us so that we can see what this looks like in practice.
Yeah, that's right. I did. I recorded myself setting up an EC2 compute instance from the Riva AMI on AWS, then configuring, setting up Riva as necessary within that EC2 instance, and finally running a Spanish to English speech-to-speech translation demo.
Awesome. Well, let's see it in practice.
Welcome to this video on running Riva on a single node in Amazon Web Services. We'll explore how to configure and launch a virtual machine instance from the NVIDIA Riva Amazon machine image, connect to that VM instance from your terminal, use a Jupyter Lab development environment on our VM instance to configure and launch the Riva server, and finally, run Spanish to English speech-to-text and speech-to-speech translation. Let's start by finding the NVIDIA Riva AMI in the AWS Marketplace. Once you've found it, click on it for more information. Then click on Launch New Instance, and finally, continue to launch through EC2 to configure a VM instance in a new browser tab. Now let's configure our VM instance. First, let's set the instance name. I've chosen Riva on AWS demo video. To minimize costs, I'll choose g4dn.xlarge as my instance type. This contains an NVIDIA T4 GPU with 16 gigabytes of memory. That should be plenty for the Spanish to English S2S pipeline we'll be running later. I'm going to use an existing key pair, but you can create a new one easily enough if necessary. For the network settings, I'll only allow custom TCP traffic from my IP address. Finally, click on the Launch Instance button. After a few moments, you should see a message indicating that the launch of your EC2 instance is underway. Click on the instance ID to inspect it in the EC2 console. A few minutes after that, your instance state should read running, and your status check should read 2 out of 2 checks passed. Click on the instance ID for more details and options. Then click on the Connect button near the top right of the screen. The SSH Client tab should tell you how to connect to your EC2 instance with SSH and your key file. However, for this particular AMI, the username is Ubuntu rather than root. Now let's use the SSH command we obtained from the EC2 console to connect to our instance. Once again, the username is Ubuntu rather than root. I'm also specifying the full path to the key file, since I'm not in the directory containing it. And voila! We're connected to our EC2 instance. The Riva AMI comes with the NGC CLI pre-installed. Once the NGC CLI is configured, you can use it to download the Riva Skills Quick Start resource folder. Let's clone the NVIDIA Riva tutorials GitHub repo, which contains the Jupyter notebook, which we'll modify and use for the S-to-S translation demo. The Reva AMI also comes with a mini Conda Python distribution, which includes Jupyter. Let's clone the base Conda environment, activate the new Conda environment, then install some dependencies which will need to run the Reva S-to-S translation demo. Unfortunately, we can't install the Reva client Python module with Conda, but we can still use pip. Let's install an IPython kernel for our Conda environment. And now let's launch Jupyter. Click on either of the links to run Jupyter in your local browser. You'll have to replace the URL or IP address with the public IP address of your EC2 instance, which you can obtain in the EC2 console. All right, now that we've started Jupyter Lab in our EC2 instance, let's launch a terminal and then open the config script in the Reva Skills Quick Start folder. Our Spanish to English S-to-S translation pipeline entails transcribing Spanish audio, translating the transcribed Spanish text to English, and then synthesizing audio from the translated English text. We should therefore set service-enabled NLP to false. We should also change the language code from ENUS to ESUS, so Reva downloads Latin American Spanish rather than US English ASR models. Finally, let's uncomment the Megatron Any to English translation model. Now that we've edited config.sh in the Reva Quick Start folder, let's run reva init.sh to download and deploy the desired models. This will take quite a while. It took nearly 40 minutes to download and deploy the ASR, NMT, and TTS models in our Spanish to English S-to-S translation pipeline. Now let's run the Reva start script to start the server. This should take a couple of minutes. Oh wow, it took less than a minute for the Reva server to start. From here, let's make a copy of the NMT basics tutorial, which we'll modify slightly to run our translation demo. Off screen, I uploaded a new audio file to my EC2 instance. It contains a recording of a coworker reading a line from Miguel de Cervantes' celebrated novel Don Quixote. I also added a cell allowing us to play that audio file. I modified the S-to-T config slightly. I enabled automatic punctuation and changed the sample rate to match that of the audio file which we're transcribing and translating. The audio file and config changes which I made in the S-to-T section also apply to the S-to-S section. I also found that I needed to add the model name parameter to the translation config component of the S-to-S config, which I didn't need to do in the S-to-T config. Finally, I modified this for loop over the streaming TTS responses slightly. I found that without these try and except statements, this cell would crash before assembling the final, fully synthesized audio clip of the translation. Now let's return to the first code cell in the S-to-T section. Run that cell and all the cells below it, and examine the results. Now let's inspect the results. First, let's play the audio file we're translating.
Cuando la vida misma parece lunática, ¿quién sabe dónde está la locura?
Though I don't speak Spanish, the text translation looks right. Now let's play the final synthesized audio clip.
When life itself seems lunatic, who knows where the madness is?
Sounds good to me. In this video, we launched an AWS EC2 instance from the Reva AMI and connected to it from a terminal. On that instance, we started the Reva server, then ran Spanish to English, speech to text, and speech to speech translation.
Great demo, Sven.
Thank you, Jasmine. Glad you liked it.
Yeah, I think it was very shocking to be able to hear when it, came back with the Spanish translation and the voice sounds so natural and real. I could not guess that there was not another human on there with us. Awesome. So, I want to let the audience know that you can ask questions anytime throughout. We'll be able to answer some of those in the chat. But what does speech AI mean?
So the three primary capabilities that we include under this ambit of speech AI are speech recognition, speech synthesis, and speech translation. Those are the things that we see customers leading with when it comes to speech AI, but also includes a number of additional things like speaker diarization and so speaker identification, things like that as well.
Yeah, I would say more succinctly, any sort of machine learning involving audio data representing human speech.
Got it. And we got to hear from some customers throughout before we saw the demo and see how customers are using Reva, but also to hear firsthand on how they apply it. But we didn't get to this. How is Reva different from the alternatives?
The primary differentiator for Reva is that it's fully customizable. We see a future where enterprises really need to own their AI, including speech AI. So they want to build speech AI pipelines that work for their domains and for their use cases. And because Reva is fully customizable, it allows them to customize any component of the pipeline and build that pipeline that they can own.
So I know that Reva is part of a larger suite of software, which is the NVIDIA AI Enterprises. How could someone access that?
You could apply for NVIDIA AI Enterprise via the form available on the NVIDIA website, and you should automatically get approved to access the NVIDIA Enterprise Catalog, which is the repository that contains all the NVIDIA software that you should be able to use to run your workloads.
And then it's also accessible on the AWS Marketplace.
Yes, absolutely. It is available on the AWS Marketplace, and Reva also has its own AMI available on the AWS Marketplace.
Got it. And then where could someone find code examples?
Oh, there are a bunch of places, but I would suggest starting in the NVIDIA Riva GitHub repo, or more accurately, set of repos. There's one with a whole bunch of code tutorials in the form of Jupyter notebooks for ASR, TTS, and NMT. There's also a repo containing a number of sample apps. The same page also contains the source codes for the NVIDIA Riva Python and C++ clients.
Got it. And then I know maybe there is some packaged AI workflows in there as well that folks could access, or is there anything like that?
Yeah, so what we did was we took a couple of the common use cases and created a workflow that customers can use to speed up their overall deployment. So we have one for audio transcription, essentially all that you need to set up this pipeline for audio transcription. We also have one for virtual assistant. So if you're looking to build a virtual assistant, you could take this workflow and then modify the components needed as needed to be able to solve for the particular use case.
And then if someone is using this, what languages are available?
For ASR, we support 14 languages today. So many of the P0, P1 languages that a lot of customers are interested in, they're already supported. When it comes to translation, we support English to 31 languages and vice versa today. And for speech synthesis, we support 4 languages today and continuing to expand that to add support for more. And another thing to note is these are the out-of-the-box languages that are available, but because Riva is customizable, you can always create your own model for your language of choice, and you can deploy that with Riva.
Got it. So in creating their own model, they could essentially train and deploy a conversational AI that's specific to them or their use case?
Yes, absolutely. So they can start with the base model that we have, and then on top of that, bring a small amount of data for the desired target language, and they can use the fine-tuning tools to create a model for that language and deploy that with Riva. It's really powerful to kind of democratize speech AI and make it work not just for the dominant languages, but for any language that a customer uses and needs AI for.
Nice. That definitely makes it applicable, for folks who have a little bit more customizable use case that they need to go in and actually build something out and train a model for something that might not exist today. So what's coming up? I heard that NVIDIA has an exciting event coming up where folks could learn more about this stuff. What's happening soon?
Yeah, we have an NVIDIA Speech AI Day coming up, and we're bringing together the NVIDIA experts and our partners and other experts from the industry to essentially show what can be done with speech AI. How can you take the speech AI capabilities available today and make it work for your own use cases?
Yeah, and I should add, Speech AI Day is September 20th, starting at 9 a.m. U.S. Pacific time.
Awesome. And we'll have a link in here that we can share as well. Is there anything else? How can people go and try it?
So Sven's demo was a great example of how you could get started. You could go to the AWS Marketplace, get the Reva AMI, and then go to NGC to get the actual container and deploy that using the AMI.
Awesome. Well, Sven, Arun, thank you so much. It's been a pleasure talking with you both. I learned so much in this session here. And so I'm excited to see what you're able to do with more customers around speech AI and Reva.
Yeah, thanks so much for your time and for the great questions, Jasmine.
Awesome. Thanks. Have a good one.